Okay, now it's a time to let us to officially start the whole program for today's workshop. So you have seen the title we sent to you. That's AI and machine learning for material science. That sounds very exciting, but I thought you may get the same feeling, similar as us at the very beginning. When we hear about these nice AI and machine learning advances, we keep thinking, how can these techniques be relevant to my work, to my life, and my research? So that is the message we hope to show today. We hope to together to see how most of us as researchers can use these state-of-the-art tools to help our work. So this workshop is brought by you by the AMD team from A-Star, NUS, and NTU. So we are the Accelerated Materials Development Program. Keep this website in your laptop or your phone, so you will be able to keep the Q&A in a real-time manner. So this Slido room 3031. If you key in that, you can ask questions anytime. We will keep some questions on our screen and try to answer it. If not, we will also send our answers later on after the workshop. Okay, so we got the website here. Okay, so my name is Xiaonan Wang. I'm from NUS Chemical and Biomolecular Engineering Department, assistant professor here. I do a lot of research using computational tools, especially nowadays, the AI and machine learning to support engineering and material research. But what are those terms? First of all, before we officially started the professional talks, the wonderful scientific content, let me give you an overview first. So you must have seen a lot of these newspapers or some reports coming out every day, telling you that AI now is so powerful, it can do a lot of stuff beyond human imagination. So these figures, like the GIF show here from Boston Dynamics, the robots can do a lot of wonderful things, so strong. From the autonomous driving system, although it's a lot of safety issues, but it's evolving fast, you got a lot of computing power to equip your vehicles to drive itself. And this kind of the face recognition, this figure recognition, you can create a lot of these kind of fake figures. You cannot tell what is real, what is fake nowadays. But all these nice advances, we bring in the professional terms, artificial intelligence, machine learning, and now the term deep learning. So what are those? We see AI, we talk about AI, want to use AI. So AI actually is any technique, it's generally any technique that programs machines to think like a human, like us, and mimic the way a person acts. So that's really very general. If you do research in electronics, in robotics, those are general AI that can be defined as those techniques to make machine learning. However, within the broad AI, we have this machine learning now. We can use a lot of these methods to help us develop some applications and benefit our life and research. So this machine learning ML, we term it in today's talks, are the statistical technique that enables learning without explicitly being programmed. So what does it mean? It's really to let the computer, let the machine to learn from the data. But if you learn, we all learned statistics in our study, in our research. So we can use these statistic tools to allow the computer to learn. So today you got a lot of programs we distribute to you. You are able to use these programs to train your machine to learn. But why is it achieving such good performance recently? We are also developing the deep learning techniques. So basically it's a class of machine learning algorithms that learn underlying features in data using neural networks. So you hear a lot of talks about neural networks today that really equip the new advances in machine learning to a deep layer. Through these different layers, a deeper and deeper layer that requires a lot of computing power to guarantee the algorithm that's able to learn more and more the hidden rules that human brain cannot process. So that is a magic power. So with this basic information in mind, we're now quite worried, will machine learning, will AI replace my job? So that's our goal today. We want to learn these things. The AI will be powerful only if there is data available. So in this stage of big data, we are all watched. We got a lot of data in our daily life. But the data has different features, has volume, velocity, different variety, and value in the data. So we are able to use the data to share the data and train our machine learning models using this big data to bring the AI, to really get the AI to benefit us, but not be conquered by the AI. So it's really a lot of different amazing domains of AI applications. If you have seen a lot of news on the healthcare, on the transport system, social media, financial service, but relevant to us in engineering and in the materials research, it's also huge potential. We can use this machine learning, deep learning, and general AI techniques to help us identify something we had never thought in that way before. That is why we have this program here, to bring you the AI techniques that you can learn and think about how to make it relevant to your research, to make it more efficient, and find some new rules from relevant to your own work. Okay, so basically, the machine learning here is that traditionally we put data in the program there and we got output. But for the programs you got today, we give you this data and then program the code in a way that the computer is able to learn from the data itself and then give you the final output as program as a black box model to tell you what happened. So that's the overview of the opening about AI. And a little bit about our program. So this accelerated materials development program has a consortium of all the faculty and the researchers from A-Star, NUS, and NTU, and we have several honorable guests today here as well, like Professor Aaron Song, who is our vice president of NUS. So he's also here as one of the team's PI, but also here to support us. So we are very honored to have many of our very renowned researchers together. And this AMD program, the goal is to use this AI and machine learning opportunities to help us enhance, accelerate the material engineering research, both discovery, diagnosis, and process optimization. So our program director is also our keynote speaker today, Professor Tang Liu, who is also giving the wonderful opening speech later on and hands-on training to you. So, and also together with Kader from A-Star, Emory A-Star, we both serve as deputy directors to make this program benefit, to make the education and the research together to benefit our community. Okay, so I will just give this overview here, and this is updated program schedule you got from email as well. The time may be a bit flexible, but we will keep all the case studies ongoing. And from one keynote and the 3 case studies, it's highly hands-on, so just keep running the code, following the step on your computers to run all the code with our wonderful speakers today. Okay, so with this, I will just start to our official technical program today. So let's introduce our first speaker, Professor Tang Liu, to our stage. And you have all seen his name, perhaps, and also got a lot of this YouTube video with this famous professor here. So Tang Liu has been a faculty member at MIT Mechanical Engineering. He founded the MIT PV lab as a very successful lab to develop a lot of energy research and applications. And he spent the past year here in Singapore to initiate this AMD program, really to bring a lot of these state-of-the-art computing technologies to help us to develop the whole AI and machine learning accelerated material program. And he's also encouraged education environment here. Without him, we could not bring all these workshops to you, trying to bring all the nice code programs and video online. So today we got the honor here to have Tang Liu to give the first opening speech to introduce how we can use AI for general materials research, and a specific example from his research team about how to use the Bayesian methods to get some material, get some physical understanding. Okay, so I will turn the stage to Tang Liu and welcome our first speaker.